Okay, so last time we have seen this Kramer rule to solve an equation of this type, right? For a square matrix, it's non-zero determinant. Let's see an example. Let's say 1, 2, 3, 0, 1 minus 4, 2, 0, 5. Okay. And then here I have x, y. Okay. All right, x, y, z. And here 2 minus 1 and 2. Okay, now we have to check whether this determinant is non-zero or not. So determinant of A. What is this? This is just okay. 5. Okay. Ve şuna göre eksi 8, eksi 3 daha eksi 11 ve minus 8. Değil mi? 5 tane buradan da pardon 2 tane eksi 11 ama minus so 2 times 8 minus 3 minus 8 minus 3 minus 11 so 5 minus 22 so minus 17. Okay, minus 17. Now let's see hani 5 eksi 22. Yanlış mı yaptım? Böyle eksi 8 eksi 3 daha evet eksi 11 2 tane eksi 11 eksi 22 5 eksi 22 de eksi 17. Tamam mı? Yani artı eksi 11 bu da eksi 17. Okay. So according to Kramer's rule, so my variables are xi, xy, z. So x is just x1. So x is just what? It is okay. Well, here I have determinant of a. That determinant of a is just minus 17. We already computed that. Efendim? 5'ten eksi 22 efendim? 5'ten 22 çıkartıyorum. Ya her şeyi anladınız bir burada mı? Neyse burada tıklıyorsanız bence yok bu iyi bir şey. Hani teorik şeyler anladıysanız sorun yok da burada anlaşamasak da sorun değil. Ya ben de çok hata yapıyorum da bu sefer doğru yaptım. Size gönderdiğim çözümleri 3 kere falan çözdüm. Her seferinde farklı çıktı.
Hocam.
2'yi ben okuyacağım öyle. O sıkıntılı bir soru ona doğru. Unuttum şimdi. Neyse boş veririz. Okay, so what is this? We write down the determinant of this matrix, right? Where the first column is replaced by this. So first column is this, and then 2, 1, 0, 3, minus 4, 5, right? Okay, so what is this? So this is minus 17. Okay, minus 17. What is this? Let me open with respect to this row. Şimdi artı, eksi, artı. So 3 times the determinant of this. Eksi 8, eksi 3 daha, eksi 11. 0 artı 5 çarpı 2 eksi eksi 2 daha 4. So, evet, böyle yazarsanız bu determinant veya or you may write this. Okay. So this is minus 33 plus 20 minus 13, right? Divided minus 17, so 13 over 17. So x is this. What about y? For the so x is this. What about y? This is just determinant of. So here I have minus 17, and then determinant. We take the matrix A. We take the matrix A and replace this time the second column with this one. So 1, 0, 2, 2 minus 1, 3, and then 3 minus 4 and 5. So what is this? Bir tane eksi 5 eksi eksi 12 artı 12 artı 7 değil mi? Eksi 5 artı 12 7. And then 2 times this one. So eksi 8 eksi eksi 3 yani artı 3 dolayısıyla eksi 5. Minus 5. So this is minus 10 minus 3 divided by this, so 3 over 17. So y is that given, and what about z? Minus 17. So this time I have first two columns, 3, 1, no, 2, 1, 0. And then the last one, 2 minus 1, 3. 2 minus 1, 3. Okay. Let me open with respect to this again row. So 2 times nedir? Şöyle yaptık. Eksi 2, bir eksi 2 daha eksi 4. Artı 3 tane, so 3 times just 1. So minus 8, minus 5, so 5 over 17. Hence the unique solution, hence the unique solution is what? X, Y, Z. This vector is just x is 13 over 17, 3 over 17, and 5 over 17. Okay. Tamam mı? Okay, now if we don't have a square matrix, and or if the determinant is 0, then of course this method doesn't work. In that case, we have either no solution or infinitely many solutions. Therefore, the story is quite different. Now, let me switch to Gaussian elimination method and explain what's going on there first, and then I will convert those solutions or the method of solution to exterior products again and explain in that language, like this one, right? So here we obtain the solution using exterior products. We will do that for general systems also, but first let me explain you what is Gaussian elimination.
It is the traditional solve.
Which one?
The Kramer.
Yeah, Kramer rule is, of course, it's a well-known thing. Usually in high school they gave this as an, told you about this. Siz görmediniz mi lisede? Her gün değiştiği için. Okay. Diğer matris bile göstermiyor. Ben siz görmüş. Filmini seyrettiniz mi? Okay. So let me go to elimination. Yani matris filmi bile sizin için eski film değil mi?
Hocam bence böyle iyi.
Efendim?
Ya şu bir çıkış tarihi 2000 ama böyle güzel duruyor yani.
Buna göre. Biz onu yani sinemada seyretmedim de Kemal Sunal filmlerini sinemada seyretmiş. Okay, so what is Gaussian elimination? Now, suppose we have a system. Suppose we have an m by n system, okay, like this one, a1, 1, x1, a1 and xn is b1, and here I have, let's say, somewhere a k1, x1, a k and xn equals bk. And then we have a m1 x1, a m8 xn em. If we have equation like this, so m equations, linear equations in m unknowns, right? They are allowed to perform such operations. What are they? We can use three types of operations to solve such systems. What are they? We can multiply an equation by a non-zero scale, right? I can multiply by an equation by, let's say, 5, if 5 is not 0 in that field. Okay? You can multiply an equation by a non-zero number, right? You can do this because you can do this because you can undo that operation, right? If you multiply with a non-zero scalar, then you can divide by that non-zero scalar and you get the same equation. So first operation is multiply one equation by a non-zero scalar. Non-zero scalar. Second, we can multiply one equation and add to another one, right? I can just add two equations and replace it by one of them. So we can replace ith equation or kth equation by kth equation plus equation plus some scalar multiple of say J equation or L equation. Yani ne yapıyoruz? Here I have, let's say, L equation, A L1 X1, and so on. A L and X and equals BL. I can multiply this equation by some number. It can be 0 and add to this equation. Okay, I can do this. Because if this is true, then lambda times that equation is true. And then this equation is also true. I just add two equations side by side. Okay, that's something we can do. But the system is still equivalent to the original system. Why again? Because I can do this. I can go backwards how to get the original system. This time I can multiply this equation by minus lambda and add to this one. Yani ikinci satırı, ikinci equation'ı 3 ile çarpıp 5.'ye ekledim. Sonra ben dedim ki ya bunu yapmasaydım. O zaman ne yaparsınız? Yine ikinciyi alırsınız. Bu sefer neyle çarpmıştım? 3 ile çarpmıştım. Bu sefer eksi 3 ile çarpar eklerim. Dolayısıyla o yaptığım işlemi geri almış olurum. Değil mi? Yani ikinci equation'ın 3 katını eklersiniz. Sonra da eksi 3 katını eklersiniz. Orijinal sistemi elde edersiniz. Dolayısıyla bu iki sistem hala aynı. Tamam mı? Yani işlem yapıyorsunuz ama sisteminizin değişmemesi lazım. Ne kastediyorum? Çözümleri değişmeyecek. Yani mesela bir satırı sıfırla çarpabilir misiniz? Çarpamazsınız çünkü bütün satırları sıfırla çarparsanız sıfır eşittir sıfır equation sistemini elde edersiniz. Onun da her şey çözümü. Değil mi? Yani çözümü olmayan şeyle sıfırla çarparsanız artık çözümü var. O yüzden sıfırla çarpmak yasak. Ama sıfırla çarpıp başka yere ekleyebilirsiniz. Yani çünkü bunu sıfırla çarpıp buraya eklersen aslında hiçbir şey eklememiş oluyor. So, what about the third one? I can just interchange two equations. Why can interchange? Change any two equations. I can interchange first equation with the third one, or second equation with the fifth one, and so on. This operations, applying this operation in a systematic way, we can obtain a simpler system. So next, you will see so-called Gaussian elimination method. To break the original system to a simpler one. What we mean by simpler one? When you look at the system, you can just write down the solution like this. I have suppose we have this equation, and then x plus y plus z equals 5 x minus y plus z equals 7. When you get this, can you write down a solution right away? No, right? I mean, it's not easy. But if your equation is like this, x equals 5, x minus 5, y equals 7, and z plus y is equal to 2. Can you solve this? Well, sure. X is 5. From this, I can find y easily, and from this, we can find z, right? So this is the simpler form. What we will do, we will see a systematic way of converting this system of equations to a system of equations like this, so that you can easily write down the solution. Solution becomes obvious. Right? So let's see how we can do that. Evet, tabii ki kafadan. Yani onlar birbirine denk değil. Okay. So what is this Gaussian elimination method? I will explain on example, okay? On example, I can use, I can write down a general system and then explain how things work, but once you understand what is going on, then you can write down the proof by yourself, okay? That's why first I want you to understand what is going on, and then you may think about, why this method works for all systems, okay? I will show you why this method works on some examples, but then you will see how you may actually prove that this method works for all systems. Okay.
Somehow looks like the bridge product, right? And somehow.
Yeah, exactly the same thing.
But if we change to of them interchange, we had minus sign, but we don't say anything there.
Yeah, but if it is equal to 0, then doesn't matter. Well, they are related. They are basically the same things, but not exactly. Okay. So let me write down some examples and see how we can understand this Gaussian elimination. Okay, so suppose we have a system like this, okay, 2x minus 3y plus 5z plus p equals 1, x minus y plus z plus 2t equals 0, and then okay, 2y minus z plus 3 equals 4, and okay, x minus plus y plus 3t equals okay, 5. Now, First, we write this in matrix form. 2. So I write the coefficients. -3, 5, 1. And then 1 minus 1 gets not z. 1, 2, 0, 2, minus 1, 1, and 1, 1, 0, 3. And then we have here. Efendim? Yani o da çözülür. Yani onu da düşünebiliriz de şimdi onu yapmak istemiyordum önce. So we have x, y, z, t and then 1, 0, 4, 5. Okay. And what I will do, I'll do operations here, and I will just translate those operations here. For example, let's say I want to get rid of this x here. Well, I can just multiply this with -1/2, this equation, and add to this one and get this one 0. But instead, let me first interchange these two, okay, and have 1 here. If you do that, if you interchange these two equations, what you do, you interchange these two rows. You don't do change here, right? You interchange equations, but this column doesn't change, but this does, right? If I interchange these two equations, these two rows will interchange, x, y, z will not change, and this ones will change. Or you may add this one to this one. So you add first equation to third one. You will add this one to this one, but again this won't change. You will just add this element to this element. Değil mi? Yani şu equation'ı buna eklerseniz elde ettiğiniz yeni sistemde x, y, z, t değişecek mi? Değişmeyecek. Burası değişecek ama. Çünkü bu equation'ı buna eklerseniz 1 + 4, 5 olacak. So this gadget, or you may just multiply one of them by 5. So you get 10y minus 5z plus 5t equals 20. So third row will be multiplied with 5. This will be multiplied with 5. But again, this won't change. So this thing never changes. Okay? That's why you don't have to carry it with you, right? Why do we, just keep writing this? It doesn't change at all. Yes.
Mesela Z'de T'yle ifade edebiliyorum. Yani ifade ettikten sonra 3 matrikse dönüştüm. Sonra T'yi bulduktan sonra derece yapamaz mı? Böyle yapamaz mı?
Yaparsın ama işte o sistematik olmaz. Yani elbette bir sürü değişik şekilde çözebilirsiniz ama ben hani bir tane bu Gaussian elimination nedir onu göstereceğim. Ama senin söylediğin gibi üçkağıtları her zaman yapabilirsiniz. Basitleştirmek için. Mümkün.
Hocam, operasyonlar sadece yolda yapılıyor değil mi?
Evet, row'larda yapacağız. But you see, since this indeterminate row, row with column with unknowns doesn't change at all, I don't need to just keep writing this. Instead, I can write this. 2 minus 3, 5, 1. 1 minus 1, 1, 2. 0, 2, minus 1, 1. 1, 1, 0, 2. Okay. And then writing this like this, instead of writing like this, I can do actually something even better to say chalk. What can I do? I can do this. Write a line here and write 1, 0, 4, 5. Okay. Now this system can be written like this. Okay. And then I will do my operations on this. Let's see. Okay, now I said first let me interchange the first and second row. Let me write here this system again. So 2 minus 3, 5, 1, 5, 1, and then 1 here. 1 minus 1, 1, 2, 0, 0, 2, minus 1, 1, 1, 1, 0, 2, and then 4 and 5. And then I'll do my operations. And whenever you make an operation, it is better to write here what you do. Because at the end, if you make a mistake, you cannot remember which operations you have done, and then you have to go all, I mean, from the beginning, it will be difficult. That's why it is better to write down which operations you make. First, what I said, let's interchange the first and second row. So I'll represent it like this. Row 1 is replaced with row 2. So we get 1 minus 1, 1, 2, 0, 2 minus 3, 5, 1, 1, and then 0, 2, minus 1, 1, 4, 1, 1, 0, 2, 5. Okay? Then what can I do? Well, I said, let me get rid of this. How can I get rid of this? I can multiply the first row by minus 2 and add to this one. So this is how we write it. The second row is replaced by what? Second row minus 2 times the first row. So I multiply the first row with minus 2 and add to second row. So first row doesn't change. What is the result? First row doesn't change. 1 minus 1, 1, 2, 0. I multiply this by minus 2, add to this one. So this becomes 0. Eksi 2 ile çarptım, artı 2. So minus 2 times minus 1 plus 2, add to this one, minus 1. Eksi 2 ile çarpıp topladım, 3. Eksi 2 ile çarpıp topladım, minus 3. Multiply with minus 2 and add to this one, well, still 1. One more. And then I have the second row, third row. And then 1, 1, 0, 2, 5. Okay. And then I will kill this guy. How can we do this? Multiply this with minus 1 and add to the last row. It will get rid of it. So minus 1 times, no, I write it this way. Fourth row is replaced by which one? Fourth row minus the first row, right? Yani bunu eksi 1 ile çarpıp topluyorum. So if you do that, okay.
Gördüğünüz gibi yani çok dikkatli olmanız lazım. Bir tanesini yanlış geçirirseniz yani acayip kötü bir şey çıkar. So you multiply with minus 1, add to this one, you get 0, 2, minus 1, and 0. This is still 5. Okay. And then we do what? Now, if you think about the system now, what you have here, you have x only in the first equation. No other equation has x in it, right? Now it is simpler. Only one equation has x in it. What I will do, I'll try to do the same thing with the second column and obtain one equation, obtain a system so that only one equation has y in it. How can I do this? Well, I can just, for example, consider on this element, and then if I add this one to this one, I can kill this guy, I can kill this guy, and I can kill this guy. So this will be only non-zero term here. All others will vanish. So that's what I'm going to do. Next. But first, let me make this one. So how can we do this? We multiply the second row with minus 1. So I can write it like this. Second row is multiplied with minus 1. Okay. So let's do that. Second row is multiplied with minus 1. Let's see what we get. Diğerlerine dokunmuyoruz. 1, eksi 1, 2, 0, 1, eksi 3, 3, eksi 1 oldu. Diğerlerine dokunmuyorum. 2, eksi 1, 1, 4, 0, 2, eksi 1, 0, 5. And then we do what? Okay, I'll use this one to kill all the other elements in that column. To kill this one, what can I do? I can just add this to this one. You see, since I have zeros here, it will not spoil this column, right? Yani birinci satırla oynamayacağım. Sadece burada oynayacağım. Buralar hep sıfır olduğu için burası yine böyle temiz kalacak. Tamam mı? Yani bozmak istemiyorsunuz. O kadar uğraştınız. Yani şunu mesela buna eklerseniz işe yaramaz. Yani yanlış olmaz ama dolanıp durursunuz. Okay, so let me mark. So I will add second equation to first one. So this means first one is replaced by first one plus the second one. Yani bunu buna ekliyorum. Eklerseniz ne olacak? 1, 0, eksi 2, 5. Bunu buna eklediniz. Minus 1, 0, 1, minus 3, 3, minus 1. Well, if you think that, you know, this will take forever, I mean, each time you write several things, you can do the following. You can do several operations in one step. For example, I took care of this one, but I can take care of this one and this one. How? So I can replace the third row with which one? Third row minus 2 times the second row, right? So multiply this with minus 2 and add to this one. So what you will get? 0, 0, eksi 2 ile çarpıp topluyorum. Artı 6, artı 5. Eksi 2 ile çarpıp topluyorum. Eksi 6, eksi 5. Eksi 2 ile çarpıp topluyorum. Artı 2, 6. And I can kill also this guy. How? Well, third row, fourth row is replaced by fourth row minus 2 times the second row. So it will be 0, 0. Eksi 1 ile çarpıp topladım değil mi? Yani yok, özür dilerim. Eksi 2 ile çarpıp topluyorum. Eksi 2 ile çarpıp toplarsam yine 5. Eksi 2 ile çarpıp topluyorum. Eksi 6. Eksi 2 ile çarpıp topluyorum. 7. But if you find this confusing, then you can just, do one operation in one step. If you just do two main operations in one step, it gets complicated and you lost the track. So one must be careful. And then we do what? Okay, I'll look at the third column. And you see I have 5 here. I can make this 1 and then kill all these guys. So let's do that. But first I have to make this 1. So what I do, I just multiply the third row with 1 over 5. So 1, 0, minus 2, 5, minus 1, 0, 1, minus 3, 3, minus 1, 0, 0, 1, minus 1, 0, 0, 5, minus 6, 5'te böldüm, değil mi? Buna bir şey yapmadım. And then we do what? We'll kill all these guys. To kill this one, I'll just add to R1 2 times R3, değil mi? Bunun 2 katını buna ekleyeceğim. Ekleyelim. 2 katını eklersek 0, pardon 1, 0. 2 katını eklediniz, burası 0 oldu. Evet. R1. Evet. R1 yerine 2 R3 artı R1. Tamam. 0 ne dedik? Ekliyorum. Yok. 2 ile çarpıp ekliyorum. Eksi 2 artı 3. 2 ile çarpıp ekliyorum. 12 bölü 5. Bu eksi 5 bölü 5. 7 bölü 5. Okay. To kill this guy, multiply with 3, right? So R2 is replaced by R2 times 3 times R2. Değil mi? 3 ile çarpıp ekliyorum. Yani bu değişmedi tabii. Yok, değişecek şimdi. 3 ile çarpıp ekliyorum. 0, 1, 0. 3 ile çarpıp ekledim. O da 0. Güzel. 3 ile çarptık. 18 bölü 5. Eksi 5. 13 bölü 5. Of course, in an exam paper, you see how much space this takes, right? There's no way you can just write down all these things on a paper. Bunu da öldürebiliriz. R5, no, not 5. Fourth row is replaced by fourth row plus minus 5 times the third row. Şuna dokunmadık. 6 bölü 5. Evet. Neyse şunu yapayım da ondan sonra söyleyeyim. 0, 0. Eksi 5 ile çarpı topladım. 0. Eksi 5 ile çarpı topladım. Artı 5, eksi 1. Eksi 5 ile çarptık. Eksi 6. 1. Evet.
Mesela biz artıyla çekmeye çalışıyoruz.
Aha.
Ondan ne artıyı bire dönüştürmeye çalışırken artıyı kullanmamız gerekiyor işaretli. Mesela R1 mesela artı artı orada. Yani
Evet.
farklı kombinasyonlar kullanarak da dönüşebiliriz ama artıyı kullanarak bire ulaşabiliyoruz.
Evet ama yani önemli olan şey matrisin geri kalanını yani şuradaki bu şeyleri bozmamamız. Yani her bir değişken sadece bir tane equation'da gözüksün. Mümkün olduğu kadar. Anladın mı? Hani bu birin altını 0 yaptım ya. Bunu bozmak istemiyorum. O yüzden birinci equation'ı alıp bir yere eklemiyorum. Okay, now what can I do? I can multiply this by minus 1. So minus R4. So what you get is 1, 0, 0, 0, 0. Right? 0, 1, 0, 0, 0, 0, 1, minus 1, 0, 0, 0, 1. And here 7 over 5, 13 over 5, 6 over 5, and minus 1. You may stop at this point, or you can kill these guys also. Ne yapalım? Okay, let's just kill these guys. Bunu eklersem, yani ne yapıyorum? R3 is replaced by R3 plus R4. Okay, so I don't change this one. I add this one to this one. So you get 0, 0, 1, 0. Bunu eklersem 1,5, 1,5. And then second one is already fine. And to kill this guy, we multiply this by minus 3 and add to this one. So first one is replaced by R1 minus 3 times R4. Okay. So 1, 0, 0, 0. 3 ile çarp ekliyorum. Eksi 15 bölü 5. Efendim? Evet, eksi 3 ile çarpacağım. Evet, eksi 3 ile çarpınca artı 3 olacak. 22 bölü evet. 22 bölü 5. So, what is the equation then? First equation is x equals 22 over 5. Y equals 13 over 5. Z equals 1 over 5. And t equals minus 1. So this is the unique solution. Okay. So x, y, z, t, which is just 22 over 5, 13 over 5, 1 over 5, and minus 1 is the unique solution. Okay. Next time, I'll give other examples where things are not like this. We will have either more equations or less equations than the number of variables. And we will see how we should proceed.